Hi guys, myself and Chandra Pratap Reddy from the Department of Electronic and Communication Engineering, studying in Srinivas Ramanuja Institute of Technology. Today we are discussing about solving methods of leveling problems. Introduction to leveling measurements. In this presentation, we will explore the process of conducting leveling measurements using a dumpy level and a 4-meter leveling step. We will learn how to calculate the reduced level of each station using the height of instrument method. Dumpy level and leveling step. A dumpy level is a surveying instrument used to measure the elevation differences between across a landscape. It features a telescope mounted on the tripod that allows the user to precisely sight and record ground elevations. This leveling staff is a graduated rod that is placed at various points on the terrain. When viewed through the Dumpy Levels telescope, the staff's marking indicate the elevations at that location. Continuous slope and interval. Continuous slope. The ground being surveyed has continuous slope, meaning the elevation changes gradually and steadily rather than abruptly. 30 meters intervals. The leveling staff readings were taken at regular 30-meter intervals along the sloping ground to capture the gradual changes in elevation. Consistent measurements. The consistent 30-meter spacing between readings allows for accurate tracking of the slope and calculation of relative elevation changes. Recorded readings. The following consecutive readings were taken using a dumpy level and a 4-meter leveling staff on a continuously sloping ground at 30 meters in intervals. First one 0.680, second one 1.455, third one 1.855, fourth one 2.330, fifth one 2.85, sixth one 3.380, seventh one 1.055, seventh one 1.860, ninth one 2.265, 3.540, 0.835, 0.945, 1.530, and last one 2.250. The instrument was shifted after the 6th and 10th readings. Instrument shifts. First shift. After the 6th reading. Second shift. After the 10th reading. Adjustments. To maintain the accurate measurements. The dumpy level instrument was shifted twice during the survey. Once after the 6th reading and again after the 10th reading. These shifts were necessary to maintain the proper position and alignment of the instrument, ensuring the accuracy of the subsequent measurements taken with the leveling step. Reduced level of first reading 80.750. First reading reduced level on benchmark BM. The reduced level RL of the first reading taken with the dumpy level and leveling staff was 80.750 meters on the benchmark. This serves as the starting point of the calculation. The RL of the subsequent reading along the continuously sloping ground. Height of the instrument method. First one, establish a benchmark. Begin by setting a known reduced level RL for the first reading location called the benchmark. Second one, measure staff readings. Take a series of staff readings at regular intervals along the continuously sloping ground. Third one, calculate reduced levels. Using the benchmark, reduce level and the step readings to calculate the RL for the each subsequent location using the height of the instrument method. Calculating the reducer levels. First one, baseline reading. Determine the reducer level of the first reading on the benchmark. Second one, height of instrument. Calculate the height of the instrument HI for the setup. Third one, reducer level. Subtract the staff reading from the HI to get reducer level RL for each station. Using the height of an instrument method, you can systematically calculate the reduced level for each station along the continuously sloping ground. This involves for the determining the baseline RL from the initial VM reading, then deriving the HI for each instrument setup, and finally subtracting this staff readings to arrive the RL for that location. This is the example for the given solving leveling problems. The height of instrument method. Points backside IS, FS, HI, RL distribute and note. Checks. First one. Hashtag of BS reading is equals to hashtag of FS reading is equals to 2. Second one, summation BS minus summation FS is equals to RL last point minus RL first point. 3.40450 minus 2.231 is equals to 99.979 minus 98.760 is equals to 1.219. Third one, hashtag of the readings is equals to 9 is equals to hashtag of points plus hashtag of TP is equals to 8 plus 1. Fourth one, sum of all RL excluding the first reduced level is equals to sum of the HI for each setup multiplied by the number of IS and FS readings taken from the setup. Sum of IS minus sum of FS. 689.741 minus 99.423 into 4 plus 100.625 into 3 is equals to 699.567 minus summation IS is equals to 7.595 minus summation FS equals to 2.231 is equals to 689.741. Interpreting the results. Understanding the Dumpy level. The Dumpy level is a surveying instrument used to measure the elevation changes across a landscape. Its readings provides the data needed to calculate the reduced levels of each station. Utilizing the leveling step. The 4 meters leveling step is a crucial tool that, when used in a conjunction with the Dumpy level, allows for precise instruments of elevation at each survey point. Visualizing the terrain. By visualizing the recorded readings and calculated reduced levels, we can begin to visualize the continuously sloping terrain and map out the landscape elevation changes. Conclusion. In conclusion, the height of instrument method has allowed us to calculate the reduced levels at each station along the continuously sloping ground. By carefully recording the leveling step readings and accounting for the instrument shifts, we can now interpret the results and gain valuable insights about the terrain. Thank you.